All right, today's topic is factoring, and factoring is basically taking something and breaking it up into parts. In the math world, you factored in the past, so if you had like 6, its factors are like 2 times 3, or you could do 6 as 1 times 6. Those are the factors of 6, the numbers that make up 6. So before we start that, we're going to do a little warm-up here, and this is basically the opposite of factoring. We're going to distribute here. We're going to multiply this monomial times this binomial, or this monomial times this trinomial, or this monomial times this binomial. So here we go. So a is going to multiply times 3a, gives me 3a squared, and a is going to multiply times 7 to give me 7a. Okay, let's pause the video. You try the next two. And we're back. We're going to do this times this. So there's an invisible 1 there in front. So negative 2 times 1 is negative 2. M to the third, because we're adding exponents. You're multiplying numbers, but adding exponents. Negative 2 times 6 is minus 12. And m times m is m squared. And then negative 2m times the, there's the different arch there. And then negative 2m times negative 1 would be plus 2m. All right, now the next one is invisible 1 right there. So it's 4 and 1 makes 4. And you multiply 4 times 1. We're going to add the exponents for x to the 5th. Times y minus 4 times 2 is 8 with the negative, so it's 8x to the third y squared. So what is all this factoring business about? So this is factoring with like regular numbers, but we're going to do this with algebraic expressions. So say we have 2x plus 8. So we're going to do the opposite thing that what we did up here. So this is considered simplest form. You can't add those together. 2x plus 8 is 2x plus 8. But I can have a common factor of 2 here. And this would be what it would look like if it was in the situation where you're going to distribute. So 2 times something makes 2x. Well, I need to have an x, right? 2 times x makes 2x. And then 2 times something makes 8. Well, how about 4? So this would be factored form, this would be simplest form, or standard form, factored form, and you should be comfortable going each direction here. Polynomials that cannot be factored are called prime. So like a prime number can't be factored. So what do we do here? Well, we're going to work on, there's different ways to factor, but we're going to work on taking out the greatest common factor. So there are several factoring methods. The approach depends upon the polynomial. We will start with by identifying and factoring out the greatest common factor, the GCF of a polynomial. So back in the day, why did you use GCF? So if you had 12 over 15 and you're going to simplify this fraction, you would think about it as 3 times 4 and 3 times 5. So 3 divided by 3 is 1. 1 times anything is itself. So this fraction of 12/15 reduces to 4/5. If you triple the bottom of the fraction, you get 15, right? You triple the denominator. You triple the numerator, you get 12. So if you triple each of those, you get that, and that's the common factor of 3. So that's why a greatest common factor is important back in elementary school, so you could reduce fractions. But we're going to use the greatest common factor to factor a number out of a algebraic expression, or number or variables. So the steps are to check the coefficients to see if there's a common factor between the coefficients. Check the variables, and we're going to take out the variables that are in common. And we divide those greatest common factors out, and then you can always check your work by distributing to make sure that it distributes back through. So here we go. We're going to go through the left-hand column like we've done in the past. So I look here, there's no variables in common. There's a 3, and 3 does divide into 12, so 3 is the common factor here. So 3 times something makes 3x. Well, of course, it's x. 3 times x makes 3x. And 3 times something makes 12, so that would be 4. So these ones here pretty easy. It doesn't have to all be in common, because like 8 doesn't divide into 36, so you have to think of a different number that's in common. So you're like, oh, 4. 4 times 2, 4 times 9. So since I'm a math teacher, I'm pretty adept at multiplying. So 4 is the common factor. So we're going to take that out by dividing it out. 4 times something makes this. How about a 2? And of course you need the m. And then I mentioned it 4 times 9, and you need the n. So I took out a number that's in common. So on the back of the page here, we're going to take out numbers and variables, but there's the common factor of 4. Excuse me. All right, now we're looking at these two. We have 6 and 27, no variables in common. 3 comes out. And what's left over? Well, let's pause it and you do it. Go. And we're back. So 3 times 2 and 3 times 9. 3 times 9 makes 27. So that's the answer for that one. Now 7 here is the first one where we get to take out a number and a variable. 21 is 3 times 7, and there's a 3 sitting there, so 3 is in common. C doesn't have any matchy-matchy, but D does, so we can take out 3D, just like the fancy movies. And 3D times something makes that. How about 7? And I need a C. I already have a D, so the D would come up there. So it's, and then this is confusing to people sometimes. The whole thing went away, but I don't leave a blank there. I leave a 1, and in fact it's going to be minus 1, because 3D times minus 1 would be minus 3D. So it's 7C minus 1. Number 9, 5, 10, 15, 20, 25, 30. So 5 is the common factor, so you can divide that by 5. Oh, no, 15. 15, because 15 divides into 15 and 15 divides into 30. Caught myself. A squared versus A. So in this situation, for the first time, we're seeing A versus A squared. So you take out the lowest amount of the A to the first, and then B and B. Well, there's a tie there, so B the first, we take the B out. Okay, so 15AB. So what's left over? Well, 15AB times something. Well, I already got the 15, I already got the B. I just need one extra A, so I need an A, because A times A makes the A squared. Okay. I already have the AB, got the AB matches. I just need a 2. So that times that makes that, and that's the answer. Down here, we have no numbers in common for the first time. We just have the A in common. So we have A and stuff left over. So A comes out. Okay, let's pause for a second. You put the answer in there. And I'm back. So A times B and 1, because A times 1 makes the A. This one here, 5 is a prime number, 13 is a prime number, X and Y aren't the same, so this thing is prime. No factoring, done. That should be everybody's favorite problem right there. Okay, next we have 2, 2, 4, so there's a 2 in common. The lowest amount of the X, so they got X squared versus X, so I do X. Y squared Y, so I got Y. So 2xy is the common. And what do I got left? Well, how about an X? And a Y. And we got to double this to get that, a 2. All right, 17, 6, 14, 10. Those are all multiples of 2 and nothing else in common, so I can take a 2 out. And I got squared, cubed, and the 4th power. So the squared, right? The squared is the smallest and lives inside of each of those. So I take out the squared. All right, so 2y squared times something makes that. Here, you fill in the blank now. Pause it for a second, see if you can fill that in. So something times this makes this. Something times this makes that. Something times this makes that. Okay? Boom, boom, boom. Fill in the blanks. And I'm back. So 2 times 3. And then I need a y squared, right? Because y squared makes y to the fourth. I need a 7, right? 2 times 7. And a y. And then minus 5. Because 2 times the 5 makes the 10. So I'm dividing, right? So essentially we're dividing like we did the other day. So it'd be like this. 6y to the fourth plus 14y to the third minus 10y squared over 2y squared. So it would be like how we did the other day. We divided this into here, divide this into here, divide this into there, and that's the answer that's left over. So that's kind of, it's related to what we did the other day. Okay, 19. 14's in common. 14 times 2 is 28. G, oh, no G in common. H squared. Take the lowest amount of H. So then I got to divide that out. So I'm dividing this into here, dividing this into here, dividing that into there. Or thinking about what I would need to distribute. What do I need? I need a G, because that'll make that. Oh, and an H, because H times H makes the H square. What do I need here? I need a 2. I already have the H, so I need a G. And that matches, so when it matches, I just put a 1, don't I? Or negative 1. This one up here, I put negative 1 because it had to be a negative. So, anyway, last two. No number in common. We got m to the third, m to the second, and m. So the lowest one, m, n squared, and n cubed. So lowest one is mn. Okay, now you see if you can fill in the blanks there. Go. So you're dividing this into here, and each one of those you're dividing that in there. All right, and go. We need an m squared. We need a minus mn and a 5n squared. The last one. 5, 10, 15, 20, 25, 30, 35. So 5's in common. We got a squared, a, and a. So a is in common. And that's it. That's it. The b squared just lives there. So no b's in common. And we fill in the blanks. 5 times something makes that. It'd be 7. And I need an extra a because a times a. Right? So 5 times 7, 35. A times a squared. How about a 4? And a b squared, and then 3, right? 5 times 3 is 15. The a comes over, boom, and that's the answer to that one. So we did the left-hand column together, and we are taking out the common factor, the greatest common factor, to completely factor it. You want to take out the greatest common factor. I almost made that mistake up here. I wanted to take 5 out of those two, and that's a common factor, but 15 is the greatest common factor. So I caught myself on that one. But essentially what we're doing here is we're taking something in simplest form. We're looking at the different terms, and we're finding the common factor, and we're dividing that common factor out so that we can make it be factored. And what is factoring? Well, back in the day, we multiplied, found different ways to multiply to make numbers. That's one way to think about factoring. And greatest common factor, back in the day, we thought about that to reduce fractions. But now we're using the greatest common factor as a thing to divide, a term to divide out of the polynomial. So the greatest common factor was 2y squared in this one. So I'm divide it into each term, and I'm left with this answer here. And that's the missing parts. So, and as I distribute this through, right, it makes the original problem. Fantastic.